We are up to 2-3, day 1. The way I see it, we're about halfway through-ish this trimester, believe it or not. Here we go. New topic, factoring quadratics. Now, that's a different way of saying factoring trinomials, because that's what this is. It's a quadratic. If you graphed it, it'd be a parabola. But now we're going to focus on the algebra and the factoring. You'll remember this from Algebra 1, I think. Now, what the heck even is factoring? Well, let's take the number 28, factor. Remember the good old factor trees from way back when? I can write 28 as 7 times 4. So these are two factors of 28. But there's more. 14 times 2 would give me 28. Negative 7 times negative 4 would give me 28. And negative 14 times negative 2 would give me 28. Yes, I could do negative 1 and negative 28. Positive 1 and positive 28, but I didn't write them down. You guys get the idea. Now we have to take these things, trinomials, try to factor them. In other words, this is a representation of a number, like 28. We got to find two things. When we multiply them together, we end up getting this. So I've nicknamed these types gotta ones because the coefficient of the squared term is a 1. Now, if that's true, you can go right to your parentheses because trinomials factor into two binomials. How do you figure out what goes in here? Well, because this is x squared, and basically you're thinking FOIL while you're doing this, because x times x gives me my x squared. So what goes here and here? Well, I take this constant and I list out all the factors, 12 times 1, negative 12 times negative 1, 6 times 2, negative 6 times negative 2, negative 4 times negative 3, 4, and 3. I think that's it. And I ask myself, see, this one adds up to 13. 12 and 1 is 13. This adds up to negative 13. This adds up to 8. This adds up to negative 8. This adds up to negative 7. This adds up to 7. So I got to take a minute and say, all right, which combination of these factors of 12 have a sum of 7? And that would be these two. So that's my answer, essentially, plus 4 and plus 3. Now, I'm not going to write out all my work, but x times x is x squared. 3x plus 4x is 7x. 4 times 3 is 12. So there we go. We factored our first trinomial / quadratic. Pause for a second. Okay, so the last example I showed you was, I gave a nickname gotta ones. These are nada ones because this is not a 1. This is not a 1. And that's the trigger that helps you decide which technique to use. On the previous one, I went right to the parentheses and then I just started to fill things in. You can still do that, but as these numbers get bigger and bigger and crazier, trial and error, I don't think it's your best friend. If you're really good at these, go for it. Trial and error, go for it. But this is a technique that'll solve all of them without a whole lot of trial and error. And trial and error on like a standardized test where it's timed, like ACT, SAT, stress goes through the roof. So here's a technique for you. I call it the rainbow technique. You take this number, multiply it by that number, hence the nickname rainbow. Not a big deal, but something to trigger. 7 times 3 is 21. Now, I'm going to now list all the factors of 21. 21 times 1, negative 21 times negative 21, 7 times 3, negative 7 times negative 3. Similar to the gotta ones, I'm now going to go through these, add them up. Whoops, negative 21 times negative 21 times 1. That would add up to negative 22. This would add up to 10. This would add up to negative 10. I want to know which one of these has a sum of 10. And I'm going to rewrite this thing. So I'm going to keep the outside term the same, 3x squared. I'm going to replace this 10x with this, 7 and 3. Now, if I just go like this, 7 plus 3, I've screwed up. Because 7 plus 3 doesn't give me 10x, it gives me 10. So I gotta make sure to put an X there and an X there. So now I've changed the way it looks, but I haven't changed its value. And then plus 7. So the next thing I do is I insert parentheses around the first two and the last two, always trying to keep a plus in between these two sets of binomials. That would be significant on this example. With this one, now I take a look at that binomial and I ask myself, what can I factor out? And the answer on this one is an X. Now if I take an X out of that, I'd have 3X. If I take an X out of that, I have a 7 plus. Now I gotta do the same thing here. And you have to factor something out. So there's nothing to factor out, but I have to take something out. So I'm gonna factor out a 1, just so I have something there. And I have 3X plus 7. I want you to notice this matches this. And if these are factorable, then these will match. So what I do is I take out whatever the match is, 3X plus 7, and I write it once, and then whatever's left, X plus 1, is my final binomial. Now, for those of you who are deep thinkers, somebody might ask, well, what if I put it in a different order? What if I take this and I go 3X squared, and then I go with this first, and then I take my 7X, and notice I still have 10X. I haven't changed its value, I just changed the way it looks. And I have a plus in here, that's good. Put parentheses on the first two and the last term, make sure you have a plus in there. What can I take out of here? A 3X. What will be left? X plus 1. What can I take out of here? A 7. What would be left? X plus 1. Notice, different strategy, but I got a pair there. I write that pair first, and then I consider it gone, because I factored it out essentially, and I'm left with 3X plus 7. Now, what's 2 times 7? 14. What if I rearrange that? That's 14. So this answer is the previous technique reversed, but they're the same thing. Okay, now let's move on to this one. This one might have a little more confusion to it, but let's start with the basics. Is that a 1 or is that not a 1? Not a 1. So I'm going to multiply that number by that number. Don't forget, this is a -3, so I get -6. And I'm going to list all my factors of -6. So -3 and 2, and then I get 3 and -2. There they are. Out of these 4 combinations, I'm looking for which one adds up to -5. And in this case, it's going to be -6 and 1. Now, please remember, over on this example, I emphasize you want a plus in between here. So I want to show you something. If I write it in this order, and I replace this with these two, so I'm going to put an X there and an X there, and I go, okay, 2X squared minus 6X plus 1X minus 3. Notice I have a plus there. Now, because I have a plus there, I'm ready to slap my parentheses in there. And now I'm going to take an X out, actually a 2X, and I'm left with X minus 3. Notice there's nothing to take out, but you have to take something out. So I'm going to take a 1 out. I'm left with X minus 3. I have a match, X minus 3's. I put those first. They're gone. I'm left with 2X plus 1. Now pause this a second. And here's the final unique thing that can happen on these not a 1s. So I got a 4, that's not a 1. Rainbow, 28. When this number gets bigger, these get a little bit more complex, but don't panic. 28 and 1, -28, -1. Again, you don't need to list them all as you get better and better. You can just go right for it if it jumps out at you. But I'm going to go 14 and 2, -14 and -2, and 7 and 4, -7, -4. Out of these 6 possibilities, which one adds up to -16? -14, -2. Now remember, I've been emphasizing that when you put parentheses in, you want a plus in between there. Now watch, it's going to challenge you a little bit. If I rewrite this, I get 4x squared minus 14x minus 2x plus 7. If I put parentheses in right now, I'm going to go like this and like this. I'm like, uh-oh, I got a minus there. That's confusing. That's why if you are forced, which we are in this case, to have a negative in there, my recommendation is take an extra step, insert a plus in there, keep the negative with the 2x, and then rewrite it like this. There's nothing wrong with this, but now I have that plus in there, and I'm sticking with the program. My opinion is that's much easier, that little trick. Now what can I take out of here? A 2x. What's left? 2x minus 7. Now here's something tricky. Remember, this has to match the next one to keep going. So what can I take out of here to actually end up getting 2x minus 7? Because I've got to have a match. I'm going to factor out a negative 1 there. A little tricky, but it works. So now I have a match. 2x minus 7 and 2x minus 1. Again, FOIL it out if you don't trust it. And there you go. Pre-lesson is done. No, it's not. I got one more thing to show you. Okay, last unique thing is called a difference of two squares. Now I'm going to teach this to you in reverse. I'm going to give you the answer first, and then show you what that produces, and then talk about factoring. So if I FOILed this out, that's why I wrote FOIL. X times x, x squared. Outside, 4x. Inside, negative 4x. Last, negative 16. Now notice what happens to these two. They cancel. So I end up with x squared minus 16. Now what you guys are going to have to do is take these differences of two squares. See, that's a perfect square, that's a perfect square. A difference means subtract. And you're going to have to factor them. Now, the technique for that, if you notice it, is one's a plus, one's a minus. Always. And then you take the square root of the first term, put it there. Take the square root of the second term, put your answer there. Notice we got what we had originally. And so what you have to be looking for is a difference of two squares. So there's a different one. And you would stick with the program. One's a plus, one's a minus. And square root of x squared is x. Square root of 25 is 5. And you're done. You factor them. One more thing. I'll just show it to you right here. A lot of students, once they learn this, difference of two squares, they think it works for a sum of two squares. So they try this, and they think they've done it right. So here's the thing. If I FOIL this out, x times x, x squared. Outside, 4x. Inside, 4x, last, 16. That would give me x squared plus 8x plus 16. Guess what? This is not factorable. That's like the number 19. You know, if you try factoring that, you get 19 and 1. That's considered prime. And that's the same thing for x squared plus 16 or any sum of two squares. Can't factor it. I think we got it.